All right, so here is our class for this Friday. We're going to go over the process for finding inverse function derivatives. So we did this with sine inverse, similar process, but in case you got stuck, here's a walkthrough on finding the derivative of inverse cosine. So if we want to find out, I'm just going to call f of x cosine x. There's f of x. F inverse of x would then be cosine inverse of x, if we start from that standpoint. This is seemingly backwards from where we're going. But if we want to find the derivative of this is g of x. We can say g prime of x is, according to the inverse function theorem, or I should say first, if it helps to write it this way, this is f inverse prime of x. We set it up that way. Sorry, this is kind of not written very well. Bear with me, please. I'm using my fingers because I don't have my pen. Hope I can find it. So, according to the inverse function rule that we found, this is 1 over f prime of f inverse of x. So, if f of x is this tells us f prime of x is negative sine x. That's good. So what we're looking for is 1 over negative sine of f inverse of x. Well, f inverse of x is cosine inverse of x. Okay, so there we go. That's our derivative. That's what it is. Now, if we want to reduce it to something that's a little more readable, we're going to have to use some trig. So this thing right here we could write as 1 over negative sine alpha, where alpha now is cosine inverse of x. And then we can rewrite this as theta. Cosine theta is x. So what this means here is that we have a triangle, theta, cosine of x is adjacent over hypotenuse. So I can just make there be a 1 on the bottom, and this tells me I can now find this side. It would be whatever that is, z squared plus x squared equals 1. So z is 1 minus x squared square root. Yes, that's what my z is. So now I'm really finding 1 over negative sine theta. What's sine theta? Sine theta would be opposite over hypotenuse. So here we got opposite over hypotenuse. So instead of sine theta, I should write 1 minus x squared, and I missed my pen, x squared square root, and that's it. So we could say g prime of x is 1 over negative square root 1 minus x squared. That's our fancy. Oh, often we put the negative in front on the top. We can do that. There you go. That's the common way we'll see. This is the derivative of cosine inverse. Okay, so that's good. Sometimes we might want to see a process several times before we can duplicate it ourselves. But hopefully by this point you can follow this process and duplicate it for the third problem. And so now we got tangent inverse. I'm going to show you my work more as a means of checking it. So f of x equals tangent of x. So f inverse is tangent inverse. And repeating this process uses a lot of good techniques, really useful techniques for solving different problems, and builds, what do you call it, fluency for doing these manipulations. both trig and algebraic using our inverse derivative rule. So here we go. If this is g of x, g prime of x, that's f inverse prime of x. Now using our inverse derivative rule, inverse function derivative rule, we got f prime of f inverse of x. Remember, this came from a chain rule. So now we know that f prime of x, derivative of tangent, is secant squared x. So we're going to say 1 over secant squared of f inverse x. So that's tangent inverse x. Okay, that's what it is. There's a derivative. But it's kind of messy. So if we make this theta, this is the same thing as 1 over secant squared theta. Secant squared theta. And so theta is tangent inverse of x. So tangent of theta equals x. Now we can make a triangle. So triangle says, here's my theta. Tangent is adjacent over hypotenuse. That's x over 1. No, that's not tangent. Tangent is opposite over adjacent. So we got x over 1 like that. So this is 1 plus x squared square root, according to our Pythagorean theorem. So now we know our relationship between theta and our angles. So if we want to find secant, what's secant of theta? Secant of theta is 1 over cosine theta. Ooh, that means I can write this over here as 1 over cosine squared theta. That becomes cosine squared theta. Okay, now I'm back to what I know. I know cosine is adjacent over hypotenuse. So this would be 1 over square root of 1 plus x squared. But since this is cosine squared, we would square that. And that leaves us 1 over 1 plus x squared. Rather simple. And so this is where g prime of x is. It's not letting me write anymore. I'm frozen. Okay, well, I think we just lost our work. So, yeah, OneNote crashed. So as a recap, you can check all these derivatives actually. You can go to inverse trig function derivatives and check all your work. Find a table. And so here's the other inverse trig function derivatives. Cosecant inverse, secant inverse, and cotangent inverse all have formulas. So that's pretty nice. Okay, so I'm going to commend to you the remaining exercises in this section, and we'll pick up after a break with a little bit of review. So I hope you guys enjoy your break. Break, I believe, is crucial to integrating all this, so don't stress too much over your break, please. All right, we'll see you after break.